Hi students, this is Lokesh. In this video we are going to discuss about the capacitance or the effective capacitance between the points A and B. So this is A and this is B. We are going to find out the effective capacitance between A and B. Now the capacitors were connected like this, and each capacitor has a capacitance of C. Okay, now we have to find the capacitance between A and B. So for you can see the symmetry here. So for this problem we use the nodal analysis for solving this very quickly. Now for A, I'll connect a positive terminal of the battery, and for B I connect the negative terminal of the battery. Okay, let us consider this battery as a has got a potential of 100 volts. So now here, as this is connected to the positive terminal, this is 100 volts. Okay, right. Now I consider that when passing through a capacitor there will be a drop in potential of X. So here it is X, here it is X is a drop, so this is 100 minus X. Okay, so similarly here also you will get 100 minus X. So here I will consider this potential as X, this potential as X, and this is connected to the negative terminal of the battery, so this is 0. So here potential is X, here potential is X, here 100 minus X, 100 minus X, and here the potential is say 50. Now once we wrote down the potentials, let us consider a point. This point is M. Okay, this junction is M. Now at that junction we can see an isolated system here. So at this junction I'll apply the junction rule. So junction rule at M. Let us take the charges here as Q1, this as Q2, and this as Q3. Now we know that sigma Q is equal to 0, Q1 plus Q2 plus Q3 is equal to 0. Now Q1 is equal to CV. CV is capacitance into potential difference. Now here potential difference is C into potential difference is X minus 100 minus X. Okay, now plus Q2 is C into CV. Capacitance is C, potential difference is X minus 50, plus here C into X minus 0, that is equal to 0. Now this is C, I will take common, so this is X minus of minus is plus, so this is X plus X is 2X, so 2X minus 100 plus X minus 50 plus X is equal to 0. Either C is equal to 0 or this thing is equal to 0. C cannot be equal to 0 because it's the capacitance of the capacitor, so this term has to be equal to 0. So this is 2X, X and X. 2X plus X is 3X, 3X plus X is 4X. So 4X minus 150, 150 is equal to 0. Then X is equal to 150 by 4, that is equal to 75 by 2 volts. So X is equal to 75 by 2 volts. Now charge flown through battery we need to calculate. Charge flown through battery, charge through battery. So how much charge is flowing through battery? Say this is q, this q is equal to, this is q3 is flowing in this direction, q3 is flowing in this direction. Due to symmetry, this also the charge is q3, and this will be say q4. So the total charge q will be equal to, q will be equal to 2q3 2q3 plus q4 plus q4, that is equal to 2 into q3 is what? q3 is c into x minus 0. X is 75 by 2 minus 0 plus q4. Q4 is what? C into this capacitance is C into 50 minus 0. So C into 50. So this value is, the total charge is, this 2 and 2 will get cancelled. This is 75C plus 50C, that is equal to 125C. So the total charge flowing through the battery, is 125C. Now effective capacitance we need to calculate. The effective capacitance C effective is equal to charge flowing through battery by the potential. Charge flown through battery by charge flowing through battery by potential across the battery, that is equal to 125C by 100, that is equal to 1.25C. Yeah, find the effective capacitance of the circuit. So the circuit was given like this. Now we have to find the effective capacitance between A and B. Now what we do is, here A, we will connect it to the positive terminal of the battery, and B, we connect it to the negative terminal of the battery. Now say, let us say that this potential difference is E. So here it is E, and this is connected to the negative terminal of the battery, so this is 0. Now if this is E, assume there is a drop in potential of X, so here it is E minus X, so here it is E minus X. Now here it is E minus X. So here, now this is 0, so this potential raise is X, so here this is X, and here this is X. Now we have done denoting the potentials of all the points in the circuit. Now applying the conservation of charge at the junction. At a junction, let us choose one junction, let us say this junction as M. Now apply the conservation of charge at the junction M, or Kirchhoff first law, or junction law, or junction rule at M. Now at M, if I apply the junction rule, so the sum of all charges is equal to 0. So this is x minus 0 into C, so C into x minus 0 plus, now this charge is x minus E minus X, C into x minus E minus X. Okay, now this done, this done. Now this also x minus E minus X, so I will write 2C into x minus E minus X, that is equal to 0. This is C into x minus E minus X, this is x minus e minus x. For these two combined, I wrote 2c into x minus e minus x. Okay, c into x minus 0. Now this gives us c into x plus 2c x minus 2c e plus 2cx is equal to 0. So this overall is this is cx, 2cx, this is 3cx, 3 plus 2 is 5cx. So this is okay. Now I will take 5cx. Now in this c common, so this is 5x minus 2e is equal to 0. Either c has to be equal to 0 or 5x minus 2e is equal to 0. The capacitance of the capacitor cannot be equal to 0, so 5x minus 2e is equal to 0. That gives 5x is equal to 2e. That gives us x is equal to 2e by 5. So the potential x is 2e by 5. Now the charge flowing through battery. Now the charge flowing through the battery, how much charge is flowing? Say this is q. Now this is q1, this is q2, and this is q3. Now if you see this one, due to symmetry, q1 is equal to q2 is equal to q3. So this is 3 times of q1, that is equal to, due to symmetry, q1 is equal to q2 is equal to q3. So q1 plus q1 plus q1, so 3q1. So that is 3 into q1 is how much? C into x. Potential difference is x. Capacitance is C. So this is 3cx. That is equal to 3 into x value is 2e by 5 into c. Okay, that is equal to 3 2s are 6, 6 ce by 5 is the charge flowing through battery. Once we know the charge flowing through battery, then capacitance C equivalent is equal to charge flowing through battery by potential. Charge flowing through battery, charge flowing through battery by potential. So that is equal to 6 CE by 5 by E. So E and E gets cancelled. This is 6 C by 5. So C equivalent is equal to 6 C by 5. This is the answer. There are some other techniques to solve this symmetry problems. One of the method is one of the technique is overlapping method. Now you can see that this is exactly the mirror image of this. Okay, say for example, if I put a mirror over here, this looks just like a image. If I put a mirror here, this looks like an image here. So one of the technique is folding technique. You fold this over this. When I fold this one, then there will be overlapping. Say this will overlap on this. So these two are parallel. Then this here, this one is here, and this will overlap on this. Okay, and this will overlap on this, because when you exactly overlap, fold it, then this will be like this. So the circuit will be reduced like this. If you just overlap it, then it will become like this. And then these two are in series, so this is C, this is C. So here you will get 2C. This is C, this is C, so this is 2C. This is C, this is C, so this is 2C. This is C, this is C, so this is 2C. This is C, this is C, so this is 2C. Now Again, this is C and this is C. These two are in series, so this is C by 2. So this is C by 2, 2C. This is 2C plus 2C and 2C are in series. So here you will get C and 2C are in parallel, and here this is 2C. Now if you calculate the C effective of this, you will get 5C by 4, that is equal to 1.25C. Now there is another method. In this method what we do is, this is exactly similar mirror image. So you can place a mirror over here, so it looks like an image. So vertical symmetry you can use. So vertical symmetry you can use. So you can remove this connection here and remove this connection over here. So that will reduce it to. So this is vertical symmetry. So here you remove this connection. If you remove this connection, then this is C, this is C. All of them, each capacitance is C. Now each capacitance is C. So here you calculate this one, effective capacitance here, this and simplify. Then we will get C effective is equal to 1.25 C. So in all these three methods we can calculate the effective capacitance.